Alright guys, welcome back to Tech Tanks. We're going to be wrapping up our segment on network scanning. This will not be wrapping up our Nmap part, however. So I was hoping to be able to wrap it up with this video, but after looking at the objectives for CEH and wanting to kind of stay focused on whatever the topic it is that we're covering, um, I can't really justify using the script engine at this point, so we'll come back and do that part later because that is a really, really powerful part of Nmap. So, like I said, we'll do it later. What we're going to be doing here today is OS fingerprinting, some banner grabbing. We're going to be looking at some IDS and firewall bypass methods, and then we're going to be. Actually, that's about it. Never mind. That's pretty much the video right there. So let's go ahead and we're going to try to get through this pretty darn quickly because the last video was pretty long and I don't want this one to be just as long. So, all right, let's go ahead and hop over here. So real quick, the lab that's currently running, we have a Ubuntu up, a Parrot, Windows 10, and Windows Server 2012. Now, we're going to be starting off with the OS fingerprinting. Understand with OS fingerprinting, there's a few different ways to be able to do it. You have passive, you have active. Each one has its advantages and disadvantages. With passive, chance of you getting caught, pretty slim. Um, the accuracy of the information, well, I guess that really depends on what they're releasing, right? And also whether or not you could do effective passive uh, OS fingerprinting is dependent upon if you're connected to the network or not. Now, in my case, obviously I'm connected to the network. It's my lab, so yeah. We're going to go ahead and just do a quick little passive here. And I'm going to just remove the filter that I have on here. And we're going to see a whole bunch of stuff going through, right? So I'm able to sniff pretty much whatever's going on the network here, which is pretty sweet. We're going to go ahead and just pick on whatever IP address this one is. Okay, and let's close these off here because it's a little much. All right, so we got 45 up here, and I believe this is the Linux system, pretty sure. But should be able to pull up the the IPv4, Internet Protocol version 4 information. And if you look right here at the time to live, that's what we're looking for. Okay. Now there's also window sizes that was brought up in the CEH materials, both version 10 and the version 11. However, I'm not going to throw that at you. Reason being is you could try to memorize it, but yikes, that's a whole lot of information. Whereas if you look at the time to live value, 64 pretty much is a Unix system. 128 is Windows, except for Windows 95, which I believe is at 32, which is just crazy. And then 255 is Cisco routers and Solaris 7. You have to memorize 3. That's it. Okay? So this right here indicates what kind of system it is you're looking at. Okay? It is not a guarantee. This value can be manipulated by the system administrators, of course. Okay? So take that for what you will. Now 35, I believe, is our Windows 10 system. So if I click over here and I go to the time to live value, 128. That was easy. And that was passive. I didn't interact with the systems at all. I didn't force them to send any data. This is just, you know, a browser, DNS. I mean, this easy stuff. Okay. Now you can do it a more active way by pinging. Okay, so if I ping 192.168.0.45, that's our Unix system. See if it responds. It does. Time to live, 64. Okay. And then if I do it to our 35 system, 128. All right. So you could see where this part's pretty easy, but do I know what kind of Windows? No. Do I know what kind of Unix system? Nope. Sure don't. So definitely limited, right? Now there are some other ways to do it. let's go ahead and hop over to the parent system. Now, the Unix system that we have up here is actually the same one that we use to set up the DVWA and the WordPress applications. Okay, so if you recall, we actually hardened those systems. So when I run telnet on here to do a banner grab on 192.168.0.45, I believe I demonstrated this in those videos, but we're going to go ahead and do get HTTP 1.1 host and 192.168.0.45 and enter. Alright, now we're actually getting an error page because I made a few configuration changes when putting it into this lab. That pretty much just screws with the WordPress. So, whatever. But what we do know is that it's running Apache. That's all we know. Now Apache running on Unix, good chance. Is it a guarantee? Nope. So again, you're kind of seeing the limitations of what we're running here. But we did harden this system. Now if we were to do the same thing, but this time on the Windows server, which has the IP address of 10, and we'll do the get, we'll be good, we'll put everything in correctly, 1.1 host, oops, 192.168.0.10, and enter. Alright, scrolling back up, and what we're looking for is actually this part. Alright, first of all, running Microsoft IIS. What are we running? Well, we're running Windows. That was pretty darn easy. But what type of Windows? Well, if you actually search the OS for IIS 8.5, one of the ones that pops up is Windows Server 2012. As a matter of fact, that is, I believe, one of the first ones to pop up. So a little bit of Googling, and you're good to go. Okay. Now, if you use this, oops, there we go. If you use this on top of the TTL, on top of the window size, you're getting a lot of good information. But there's actually some easier ways to do it, but it's definitely more active as well, which this would be considered active because we are directly interacting with the quote-unquote target. But the other way to do this is running good old-fashioned nmap O, and we'll start off again against, well, actually this time we're going to start off against the server. Okay. Now with the server, you're going to get some pretty specific results in a minute. Any minute now. Here we go. There we go. All right. OS running Windows 2012. Server 2012 R2. OS details, it's running this or it's running this. But gosh darn it, that's pretty narrowed, right? And for the record, we are running the R2. You can see that right here. We're running our evaluation version. So we're going to go ahead and clear that out. And reminder, that is a capital O. Okay, not a zero, not a lowercase o, capital O. And we're going to go ahead and clear this. And we're going to do the same thing again. But this time we're going to switch it to 45. Now, again, we hardened this system. So not going to be a whole lot of information provided. I mean, we do know it's running Apache. That was pretty easy to find. But as far as for the OS part, you're going to get a whole lot of options here. Okay, and it's aggressive OS guesses. Well, we're 95% sure it's this one. We're 93% sure it's this one. 93 this one. 93 this one. 92, 92, 92. I mean, we know it's Linux, right? It's not giving any Windows options, so we know it's Linux. Now, there's ways you can actually manipulate this to make it even worse. I could get this to even suggest that it's a Windows system. Okay, so it all depends on how things are configured as far as for what kind of information you're going to be getting out of it. Okay, now if you use that in combination with the information you're getting on the ports, you know, especially if you're checking the version of what you're getting on the ports, like the services that are running, it's going to narrow it down even more, just based off of that information. Okay. Now, the next thing we're going to do here is, so that's our OS fingerprinting and banner grabbing. Okay. And, you know, it's a good way to get some information, but There is no guarantee on how accurate that information is going to be. But that is what you need to know for your CEH exam, whether it be the 10 or the 11. Okay, although Telnet, the banner grabbing with that is not in the CEH version 11 reading material, I believe. Pretty positive it's not. It is in the version 10, however. So take that for what you will. So moving on, we're going to discuss some IDS evasion techniques. Understand, and firewall. Sorry, IDS and firewall. Understand that this is not a guarantee for any of these methods for multiple reasons. It all depends on how it's configured, and there's so many options on how to configure this stuff that it's, you know, try the different methods. You know, through experience, you figure out, okay, it seems to be blocking this or something like that. You know, it's kind of like, you know, hopefully by this point you've at least tried breaking into Wi-Fi, your own Wi-Fi legally, totally on an ethical level. And if you have, try doing it when there's MAC filtering involved. There's a way to bypass it, and it's pretty easy to determine if it's doing MAC filtering. So, you know, that kind of experience, you learn along with the IDS and firewalls. Okay, it seems to be blocking this. I can bypass it with this, and that sort of thing. So anyway, one thing that does tend to come up is that it blocks, like a firewall is set up to block certain packets or certain packet information. Okay. The way to get around that is you can try to fragment your packets. Okay, that's option number one. What's that? I need to double check the IP address on this one. I think it's 30. Yep. Okay, cool. I'm just setting up for Wireshark here. Okay. All right. So what we're going to do here first, we're going to just run a typical nmap. We're going to specify port 80 for brevity purposes. And we're going to target our server. Okay, we're going to send it on through. I want to pull up server so that way you guys can see what's coming through, because there's a couple things to show you. One, there's that, right? Scan port 80. Two, notice I didn't specify for it to do a stealth scan, and if you watch the video from yesterday, that's what this is. It sends a SYN packet, receives the SYN acknowledge, and then it resets. Done. Okay? This is not a full connection scan. That is the default scan for Nmap. Okay, so if you don't specify a scan type, it will automatically do the stealth scan. Okay? Other than that, everything looks pretty standard. Cool. Let's go back to Parrot here. Alright. And what I'm going to do is I'm going to add a scan alteration, we'll call it. Okay? Just a lowercase f flag. Alright? When I do that, that tells the Nmap scanner to fragment our packets. Okay, so I'm going to go ahead and send that through, and then I'm going to bring up the server so you can see the slight difference. Okay. Fragmented. Okay, and there's two reasons why I want to show you this. One, there's your difference. It shows two fragmented packets, and then it put everything together, and other than that, we get the same outcome here. And by the way, we also get the same results. You can see that right here. Port 80, everything's the same. Now keep in mind it's only doing port 80 because that's the only one I told it to scan. Okay? Now, the reason why this part is relevant is this works unless they set up a specific rule in the firewall to not accept fragmented packets, in which case this no longer works. Because as you can see, it recognizes that it's fragmented, right? So there's that part for you. Okay, so again, a decent method. It's kind of fun, but my favorite one is actually coming up right now, which we don't need this for that. We need the control panel. So I set up a firewall rule. Okay, I can't set up a rule for everything because that'd just take too much time. I don't want to do it. So, whoops. Oh no, I was right. No, it wasn't. Oh, yeah, I am. Wow. It's a day, guys. Alright. I'm going to go to advanced settings in the firewall. Notice that the firewall was on. Okay, and I created an inbound rule called the blocker. Alright. just to quickly show you what this does, it looks for the protocol type TCP. And by the way, this is actually pretty common. This is why we did the UDP ping scan last time, because a lot of times companies will worry about TCP, because TCP, you always hear about TCP, right? HTTP uses TCP protocol, SSH, FTP, all this stuff uses TCP. They forget about UDP being an option. So in this case, so basically, just kind of summing that part up, you're able to, if you're able to do something through the UDP channel, and like if the TCP is not working, try UDP. You'd be surprised how often it works. Anyway, protocol type TCP, all ports. The remote port is where this becomes relevant. I set it for 1 through 79 and 81 through 65,535. So I covered every single port except for 80. And what I told it to do is block it. Okay, don't allow it. So we're going to go ahead and enable this. And then I'm going to go ahead and just run a typical scan. Okay, using Parrot. I'm going to just do a nmap 192.168.0.10, and we're going to run it. We're not going to worry about what it shows on Wireshark, because it's not really relevant at this point. You already saw the rule. You know what the rule is. You know what's going to happen. It's going to just drop everything. Takes a while, though. I'm not going to lie to you. As you can see. Still waiting. And there it goes. And it says all ports are filtered. Now we know that's not true because it's hosting a web server, right? But I told it to block everything not coming from port 80. So Nmap has an option to manipulate the source port to whatever one you want. Now there are ways to figure out if there are specific ports being allowed, and usually the rule of thumb, guys, just try the well-known ports: 80, 22, 21, 443, things like that. So I'm going to go ahead and run 80. Again, it's going to take a moment, but you're going to see an entirely different result. And then after this, I'm going to go ahead and shut off that thing. So there you go. Now we're done, and it shows all those open ports before. Okay? So what we're going to do here now is we're going to go ahead and just shut that off, because I don't want to keep that on. That's going to just make things annoying. So we'll just disable it for now. Okay? We'll leave the firewall itself on. The next thing I'm going to show you here, okay, that is one way to bypass a firewall that's set to block anything that's not a well-known port. Okay. Now, the next one we're going to do, sometimes to evade an IDS, it's not to stay, well, no, it's to stay hidden. That is really the only way to avoid an IDS. Stay hidden. If you're going to be scanning a network, you're probably going to be setting it off. Let's be real here. Okay. If the firewall isn't the one blocking you, but you just simply don't want to get caught with what you're doing, you may need to create some decoys. All right. Nmap has a couple of really cool ways to do decoys. We're going to just do a random number of 10, and then we're going to just scan our buddy here. Although I am going to tell it to focus on port 80 now that I think about it, because again, brevity purposes. All right. So port 80, we're going to use decoys, and I almost forgot to put this up. I actually had to redo this video because I forgot to bring up Parrot again. So we're going to tell it to do port 80 and run decoys, a random number, 8 specifically, or a random IP addresses, specifically 8 random IP addresses, and here's our target. Okay. Now, I am going to switch back over to the server because I do want to show you how this whole thing goes down. Okay. And what I'm going to do is I'm going to switch the filter to be TCP port equals 80. Okay. And as you can see, we got a lot here. So continue without saving. Reapply this. All right. I'm going to go ahead and send through that scan now. And you're going to just see a bunch of different IP addresses pop up on here. And ours is going to be hidden inside of there. So this one, this one, this one, this one. There's the real one. This one and this one. Okay. Now the reason why it does that is it basically is saying, is like, oh, a bunch of random, IP addresses. Who's sending the actual packet? So the idea here is hiding in plain sight with a lot of others, hiding in the crowd basically. Okay, and you can set this for a lot of different random numbers. I chose 8, but you can set it for like 2, you can set it for 20, kind of whatever. Now maybe what you want to do is, you want it to be specific for whatever reason. Maybe you're already inside of the network and you're wanting to basically send through, a bunch of in the network addresses. Okay, so we'll say, you're doing the 192 thing, right? So it's like, all right, well, I wanted to do 192.168.0.20 and 192.168.0.33 and 192.168.0.41, so on and so forth. And you can add in as many as you want, and you can even add in the real IP address. So for example, if I wanted to put my address to be the third one every single time, I would put it right here, comma, and then I would, add in the 41 like I have here. This is how you set it up. Now notice there's no spaces after the commas. Okay, that's important. So we're going to just keep it with these ones here, and then we're going to go ahead and just reset. Oh man, I almost forgot again. See, here you go. I got it up here. So fake IP address, comma, no space, fake IP address, comma, no space, fake IP address. Now I didn't add in the real IP address here, which means it's going to randomly place it. Okay, now we're going to go back here. Man, I almost forgot. I can't believe that. I have to redo this video again. I'm going to be irritated. Okay, we're going to make sure that's set to port 80 again. We're sending it to port 80 for the scan. Ready, set, go. Okay, and you can see 30, 20, 33, 41, 10. So this time it actually put in my IP address first and foremost. Okay, so there you go. That is using decoys. All right, now let's see, covered that. Spoofing. All right, now here's the deal. Spoofing is kind of a bittersweet thing. It is used quite a bit. However, it is not used a whole lot for scanning purposes. Reason being, you can't complete a TCP connection scan if the target, so to speak, is sending the SYN acknowledge packet to a different computer, right? You can't be a part of that scan at that point. So spoofing does have a place in hacking, just not a whole lot when it comes to the scanning of a network. Now there are uses for it. I'm not going to say it's never used, but we're going to call this an IDS or firewall evasion technique. And I'm going to just show you real quick one method, pretty simple. HPing3. The target is going to be 192.168.0.10, and the decoy is going to be 7.7.7.7. Sounds good. All right. Oh, and yeah, we're going to just leave it at that. So what I'm going to do here is I'm going to set this IP.address is going to be equal to 7.7.7.7. Start it. Continue without saving. Apply it. And then we should see it pop up here. Oh, man. That anticlimactic moment. There we go. And we can see it's now getting information from 7777. So, alright, we're going to go ahead and cut that out. So that is spoofing the IP address. Again, it is relevant, and HPing3 actually has this pretty cool thing where it will try to overload a server. We'll get into that one later. Yeah, so there's everything for you guys. Now, real quick, to kind of prevent this from happening, I mean, guys, it's just great configuration. Oh, you know what? There is one more thing I wanted to show you. Never mind. hold up, one more thing. All right, we're going to target our server with, oh, you know what? There's the 7777 thing that I was showing you. Sorry, or that I was talking about. Sorry. All right, I did want to show you guys. So I'm going to use that hping thing again. But this time, I'm actually going to change the IP address. I'm going to use the Windows 10 system. Okay. And I want to show you, you can actually determine if a packet is spoofed. I don't think you're going to want to do this with every packet, but this is just as an FYI. You can pick and choose where this might be relevant. Okay, now this does not always work. Again, it's going on, assuming that defaults are being ran, right? So I'm going to go ahead and run this one more time. I'm going to come over here and reset this. Okay. And we're only going to run this for a moment here. So it's coming from our Windows 10 system. That's what it's claiming anyway. So let's run this. And let's wait for some data to show up here. Oh. That's funny. 192.168.0.35. Boom. And all of a sudden we have a lot of packets. All right, cool. Let me go ahead and close this. I'm going to bring the server up. Okay. Because this is, I actually showed you this earlier. So we'll see if you can kind of see where I'm going with this. So we see a lot of packets coming from 35, right? So if we look at that time to live value though, showing 64. And I'm thinking, I know that IP address and it's a Windows system. Let's try this. Now here's the thing, it doesn't necessarily have to just be the defaults. Okay? If it's saying that the time to live is 93. Okay? Like, well, let's see here. Ping 192.168.0.35. Those time to live values don't match. Interesting. Okay, that indicates it is spoofed. All right, you can compare the time to live values. Now, again, this is running off of the same network, so take that for what you will. There's pretty much no hop time. So obviously we're going to get pure values here, but this still applies. I mean, say it had to go through 10 hops. Now it says the time to live is 54. If I ping the address and it's like the time to live is 10, because there's so many hops in between, or the time to live is 60, something doesn't quite seem right here. Okay, even if they're both Unix systems or they're both Windows systems, something doesn't quite seem right. Okay, so you can compare the time to live values and kind of go off of that. Now this also works with, all right, well I'm going to trace route this, and I'm going to see how many hops there are. I'm going to do a little bit of basic subtraction and all that. There are ways to figure out it is spoofed. All right. Now other options as far as for evading IDSs, or specifically firewalls I should say, are using proxies or anonymizers, because if it's IP address related or anything like that. But to prevent this stuff, guys, close ports that you don't need. Don't give away any more information than you have to. Make sure your firewall, your IDS, your IPS, make sure these are configured really well. Okay, it is important to make sure that they are configured well. Now, last couple things I wanted to go over with you real quick. I said I was going to show you guys where the scripts are located, but also I want to talk about real quick to specify ports with Nmap. You saw me use this flag. That would be the way to do it. Okay, and you could do like 22, 80, that sort of thing. You can do 22 through 80. Another shortcut is just doing this. This tells it to scan all 65,535 ports. It's a big scan, I'm telling you now. The other one, I mentioned it last night, and I think I was given some bad information. It was late. The options for the T are 0 through 5. 0, it's going to crawl. 5, it is going to blaze through it. Now keep in mind there's advantages and disadvantages for both of those. The obvious advantage for running it at T5 is it will be blazing fast. That's the whole goal, right? The drawback is a couple things. One, That is a great way to trigger an IDS system. um, when all of a sudden it's like, wow, in the last second I've had 50 attempted connections from this one device on different ports. Um, that's a huge red flag. The other disadvantage, though, is if you're going too fast and the network's not able to keep up, you're going to actually miss some data. So if you run these scans too fast, you may see that certain ports are not open that actually are. So there you go. If you run it too slow, or the disadvantage to running it slow is it could be slow, very, very slow. Okay. Um, that's really the only disadvantage to it because it is less likely to be caught because it's not running a ridiculous amount of connection attempts rapidly. It's doing it pretty slow increments. Okay. So you have your tiers. Now, if you're wanting to run a script, okay, I've seen a couple different ways to do it, but I'm going to just use the method that is actually brought up specifically in CEH, and it's also the one that I use personally. But you do script, and then you put the name of the script, whatever it may be, right there. And then you give it its target, necessary ports, whatever the case may be. You can run multiple scripts. We'll get into that part later. Let me show you. You can look at these here. Okay, now if you have a system admin that's stored them somewhere different, well, can't help you there. But this is the default. And you can see there are a lot of scripts. Okay, still going, still going, still going, still going, still going. Some of these check for vulnerabilities. Some of these check for specific vulnerabilities. Some of these check for, like they enumerate it for you, like enumerating um, your file shares and things like this. So these are fantastic. We will get into using them as we, do some enumeration options and things like that. Okay. So there's your video, guys. I did keep this one a little bit shorter, 32 minutes. Hot diggity dog. I'll see you guys in the next episode.